in a low carb. Got it? So examine the weight gain in the low carbohydrate diet versus low fat diet in broiler chicken. So the study one, we have 20 kilogram per 30-day weight gain, and the number of participants is 15. So in the another study, sorry?
Excuse me, madam, can you put it in a full screen, the slide?
Oh, sorry.
Yeah.
Sorry. Is that okay now?
Yes, madam.
Yes, okay now.
Okay. So I'm just going to explain a little bit about weighting. So if you have two studies, one study with the 15 participants or the 15 broiler chicken, and the other study is 30 chicken. And then we recorded the weight gain as 2 kilograms per 30 days and 3 kilograms per 30 days. How do you get this effect size, overall effect size? How do you get that one? Or are we going to use that 1.5 kilogram for as a average? What do you think? Is that right if we use that? Come on, guys, yes or no? So the first study has 30 participants, second study 15 participants, second study 30 participants. So definitely if we have more participants, then we can expect better results than the small number of participants in the study. So actually we need to consider the precision of the estimate for each study. So the sample size is a key component of study precision, and studies that are more precise should have more weighting in the summary estimate. So the information about the study precision is found in the standard error. How do you calculate standard error? So the standard error of the mean, or the SEM, standard deviation of sample divided by square root of n number of participants. So this is kind of what we usually used. And increasing the sample size reduces the standard error of the mean. And also increasing the sample size will also reduce the standard error of the effect size. But we try to do it how to have a effect size measurements. Okay. What we want is the weight the studies with the smaller standard errors more relative to the studies with the larger standard errors. Okay, so therefore we could use the inverse variance weight or weighted factor, which is inverse to the effect size variance. I'm really sorry, today I have to talk about a little bit more about statistics. If you don't understand, just ask me in a chat, or you could send me maybe Dr. Chinta can give the maybe you can forward the questions to Dr. Chinta so she can forward to me. So so the weight is the 1 over standard error square. Okay, so please remember this equation for a minute. I'm going to use it again for another slide. Okay. The weighted mean effect size can then be calculated by summing the individual weight effect sizes and dividing by the sum of the weighting factors. Okay, so so what are we going to do if studies have different effect sizes? Anyone can contribute? So it's actually, there's no specific method, but it's depend on the researcher, and you can extract the most suitable effect size. But sometimes if you have the multivariate analysis, so it's difficult to, because in the multivariate analysis, you have one Y variable and many X variables, and then Y variable with one X variable is usually not, I mean, the univariate analysis and bivariate analysis not always possible to see in the multivariate analysis reports. Okay, so and then the next question arises, so, okay, so we have effect sizes. So how through these effect sizes? So for that, we could use, as in the other calculations, like confidence interval. So you know that 95% confidence interval, the Z value is 1.96. And so the 95% confidence interval for the mean effect size is equals mean effect size plus or minus Z times standard error of the mean effect size. So this 95% confidence interval not contains 0, then we could say that it is statistically significant. Okay, that's for the how do we calculate effect sizes. The summary of the effect sizes is in the meta-analysis what we call forest plot. So that forest plot allows researchers to summarize in multiple studies. This is the example of one of the forest plot. So, and also it gives you the uncertainties of the, confidence intervals of each of the study, and also information about the heterogeneity, and also weight. That weight is actually, you can show it in this forest plot. Okay, this is the more elaborate example of a forest plot. I'll give you a few minutes to look at it. Can you guys see this clearly?
Yes, madam.
Yes, madam.
Okay, please ask questions if you have about, now some of you already go through this literature, what I suggested last week. So I'll give you a few minutes to look at it and then we'll discuss it. Okay. So forest plot is actually, it's not kind of forest, but it's easy to have a name for this kind of thing. So this is one study, or maybe the subgroup. You could use a subgroup for that one. And in this example, it is about the risk ratio. So the as you can see, this one line with the blue square is indicate a one study. Okay, so the second study is here, third, fourth, fifth, and the width of the line represent the confidence interval, and then point estimate that the true effect of the proportion in the population in the study. Most likely this is the weight, and here is the no effect, that signifies no difference. Okay, here is no effect. Okay, this diamond is important. This is more like a overall effect estimates. So and also this is what we are actually looking for in whole studies. So this is I square, and this here p-value. So any questions regarding this forest plot, or any more explanations you guys need? Okay, so I just yes.
I have a question, ma'am.
Okay, so the previous
Hello.
one.
The previous graph here.
Yeah.
Yeah. What is the meaning of the favors experimental and favors control? They have point 0.01 to 100 level. The overall value is not less than 1%. One. What does it mean?
So here favors control means if this is go to this side, then it is favors to the control. But if this is go to the other side, it favors the experiment what you did. Think about that. You have mean difference of means kind of experiment. So one is actually a control, isn't it? What I mean is the control is that so is the normal conditions, and we doing the experimental conditions. So if it is more like a normal condition, it goes to the right side. It favors to the experimental conditions, then it goes to the left side. We can discuss this one in when we are doing a meta-analysis examples in R in next week. So I'll explain it more detail with using the few of the examples.
Thank you.
Is that clear? You want more explanation?
Yeah, no, thank you very much. I can understand. Maybe we can I will join the next class to get the more information.
Okay, so these are, I just summarize each of these parts of the forest plot. So just leave it for a minute. Going back again to the previous one. So each of these, the list explain all of these things. For example, this blue square is a weight given to, so this study has more weight than this study. And as you can see also that the confidence interval is narrow, and this one is a wider confidence interval. If the confidence interval wider means that is more like a high variation in your results. Okay, so this one is quite good study in this. I think it's study 6. Okay, and so how do we interpret the forest plot? The diamond shaped figure, which I talked before, this one here, this figure. Overall effect size, the width of the diamond represents the amount of uncertainty surrounding the estimated effect size. So if it is narrow, so that it's very kind of like certain studies. And horizontal line, each research effect size. If the line has 0, it signifies that there is insufficient data to demonstrate a meaningful effect size from the intervention or treatment under consideration. Findings of outlier or discrepancies. Horizontal lines that are substantially longer or shorter than the rest. This might imply that the findings of one look post study are inconsistent with those others. Okay. And also direction of the effect site. If most of the lines are to the right of the 0, it indicates that the intervention or treatment had a favorable effect. Negative influences left to the 0. Okay. So consider the magnitude of study, indicate the weight allotted to each study in the analysis. So then I'm going to looking at the heterogeneity. You know, the studies are not homogeneous, so different researchers do these studies, and we cannot say that all are the homogeneous studies. So if we think about that, individual study effect sizes estimate the same underlying true effect size. Or do we think that it may have a different effects, underlying effect sizes? So, and then we kind of introducing a 2 effect size model, fixed effect and random effects models. In fixed effect models assumes one underlying population effect size. So the individual variation is due to the random sampling. And then random effects models. So it's not only the random sampling, but also the some other underlying unidentified sources. Okay, and then this is bit more heavily statistics related. Heterogeneity assessment for fixed effect models. We could use Cochrane's Q statistics, and
Excuse me,
also,
madam.
sorry.
Madam, can you please give me some the explanation about the random effect and the fixed effect model some more?
I'm going to discuss in a few minutes time. Okay, so I'm just first thing is try to explain it in a statistical measures. Okay, so Cochrane Q statistics and I statistics, that's the both. We could use both. And then Q statistics is more like what we are looking at the some kind of how do you say that? Some kind of arbitrary value, as the all studies are homogeneous, and then we think about the one value of the heterogeneous and then looking at that heterogeneous value. For example, so the Q statistics has chi-square distribution with K minus. K means the number of effect sizes, the number of studies, and this is the degree of freedom what we usually talk about. And if the observed Q statistics over the critical value, that's the critical value what I'm talking about. That's the p-value, then less than alpha, then the null hypothesis is rejected. Okay, so but we always know that the effect sizes are always heterogeneous. So rather than these arbitrary values, we could think about the variation I square, or the variation amount of variation, the effect sizes that would remain if we could remove sampling error. Okay, so in this I square values, this Borestein, the one of the authors talk about meta-analysis heavily. So 25% is, if I square is 25%, it's low, and if more than 75, it's high. And there's another one called Cochrane training. So this it said that 0 to 40% might not be important, and then 60 to 90% substantial. So random effects models, the one I talked before is about, sorry guys, just move this one. Fixed effect model, how do we find the fixed effect models? And then random effects models, this assume that the not only the sampling error, but also other sources of variability. So so if we think about the variability of the random effect, so it consists two things. One is the sampling error, and the other one is the between studies variance. This is sampling error, this is between studies variance. So the random effects models, we need to calculate the tau squared. This is bit technical, and there are many ways to do that. So usually the Simonian OLED method, or in metaphor package, it's used RAML and all sort of things. So you could refer this one with the Cochrane handbook. I think I already gave you guys the, okay, so which model are you going to use? Random or fixed model? This is the question one of you asked a few minutes ago. So it's actually depend on the researcher's view about the model, but more likely first you need to run it as a fixed effect model, and then explore the Q or the I values. And then if heterogeneity is not significant, use a fixed effect model. And if it is significant, then we need to repeat the analysis with random model. Is that clear? One of you asked a question about that. How do you use the random? Yeah.
Madam, can you repeat that words again, madam? Because I couldn't catch that, what you have mentioned.
Okay. So I just go back to previous few slides. Okay. Okay, here. So fixed effect model, how do we, yes, I think previous one. Fixed effect model assumes one underlying population size. It becomes because of the individual variation due to random sampling. Random effects assumes that there are differences in underlying effect sizes, so source cannot be identified. Okay, so before we run that one, we need to find a statistically measures Cochrane Q statistics or I-square statistics. How do you do that one? I think these are really done. You can do it using the software. So what I really want to emphasize here that this I square value is less than 25. That means it's low. 50 is moderate and 75 is high. Okay, so these two are Q statistics and I square statistics. You could explain in a one or two equations, but for the random effects models, this is a bit complicated because we actually don't know the other sources of variability. Only to mathematically we could show that. Okay, so and then the calculating this tau sphere is a bit difficult. So that's why we first do the analysis with the fixed effect model. And then we look at the heterogeneity, the I square or the Q statistics. And then if it is not significant, then we use fixed effect model. If it is significant, or for example, more than 60%, then we have to do the random model. It bit complicated, but software can run these models without any difficulty. Okay, so these are some of the things I asked to find for me because I asked this from the ChatGPT. Chinta, the students are allowed to use ChatGPT?
ChatGPT free version, I think they can use, not allowed.
Okay.
Our Trinitron also facilitate with AI tool to detect that one.
Okay. So I'm just asking that because in some of the in Sydney University, most of the courses are allowed to use the ChatGPT, but you have to tell how you use and what are the prompts you use for the asking. Okay, so these are the kind of comparison given to me by the ChatGPT. It's quite good, so I just leave it like that. Okay, so this is the and these are the other similarities or the differences. Okay. So, and then if I go back to my previous day's notes, so we have few steps to run for the meta-analysis. So, and then the most importantly, we should think about what kind of bias or sources of bias we could include in our studies. So the main thing is a selection bias, because we only choose studies familiar with those support their viewpoint. Differences in characteristics between those who are selected for study. So we actually kind of doing selection bias because we are the ones selecting the studies for meta-analysis. And also there's another one called performance bias. Differences between groups in the care that is provided or exposure to factors other than the interventions of interest. Okay, so we have not only our interest, but other interest looking by the researchers. And also we kind of have a detection bias, differences between groups in how outcomes are determined. So, and also attrition bias, differences between groups in withdrawals from the study. Reporting bias seems like difference between, just give me a minute. Just drop this one for. So, sorry about that. Differences, publication bias. This is the most important thing we need to look at it, that only select studies which have been published. So in general, studies with statistically significant or positive results are more likely to be published than those with non-significant or negative results. Because we think that negative results is not accepted by the journals. So we tend to not to show any of the non-significant or negative results. And also, there's also language bias. Only select studies written in English, or at least we read the English abstract. And the last thing is the indexing bias. Only search a limited number of databases or use a limited choice of search terms. So in generally, if you have a lot of studies, then the meta-analysis is more productive in that way. Okay. So next thing I want to talk about is strategies to address the publication bias. So actually publication bias, it's very difficult us to get away with that. Only thing we can do is to find a way to minimize those publication bias. So the first thing is comprehensive literature search. Use multiple databases and include gray literature. Perform hand searching of reference list. So, and also we could use assessment methods such as funnel plots, which I'm going to talk about in next few slides, or the Eggers test about the funnel plot asymmetry. And also trim and fill method is also we could use in the missing studies in the funnel plot. So, and also we could use statistical methods to correct bias. This P-curve analysis, corpus selection model, or the dual and 3D's trim and fill methods. And also we could run the sensitivity analysis. Exclude small studies, like effect sizes changes by excluding the smaller studies. And also we could run the subgroup analysis, compare results across different study subsets. Reporting bias indicators, evaluate heterogeneity and risk of bias using tools like the Cochrane risk score bias tool, and also registration and protocol. Register meta-analysis protocol, and also follow the registered protocols and report any deviation. Publication bias. Sorry, any questions about regarding the previous slide? Or the
Excuse me, madam.
Yeah.
So in order to avoid the publication biases, so do we have to follow all the methods, or can we use one single method that you listed?
Actually, publication bias, it's very hard for us to correct. Okay, so only thing we can have add more studies for our meta-analysis. Then we could somewhat get away with that. We cannot get away fully get away with that one. We could tell, like this statistical methods of funnel plot, you could say that it is in between confidence intervals or not, or things like that. These two are more important, like comprehensive literature search and the statistical method to correct bias. These two what we can do it. If we can do all, that's good, but sometimes it's very hard to do all of these things.
Okay.
Can I have a couple of questions, ma'am?
Yeah.
One is the databases you mentioned. So how
Yeah.
many databases would you recommend for a meta-analysis? I don't think we can go for so many databases, but there may be some acceptable numbers. That is first question. Second one is we talk about outliers.
Yeah.
Other experiments. So do you come across any kind of outliers, and that can we overcome these outlier issues in meta-analysis?
The first question is about databases, isn't it? So the databases, I think there are many, at least not only one, like Web of Sciences or SciFinder Scholar or current content, maybe 2 or 3, not only one database, but at least 2 or 3 databases. Searching 2 or 3 databases is kind of recommended for meta-analysis, especially for the Sorry?
If I say it is more less than 5, it would be okay?
You mean number of studies, what you're talking?
No, databases. Now we can go for PubMed and then go for Google Scholar and
Yeah.
elsewhere. Maybe less than
If
5.
you can go for 5, that's very good, isn't it?
Okay. So there may be repetitions then.
Yeah, it's always repeated. For the biological researchers, Web of Science is really comprehensive, isn't it? So you could have different keywords, and also SciFinder Scholar is also good. For the PubMed and the Cochrane, all those things for medical researchers,
Yeah.
which I'm not really familiar with.
Yeah.
I'm really familiar with Web of Science and SciFinder Scholar, and also current content, but the current content is actually have the abstract only, isn't it? So once you go through the current content, and then you can find the search the paper, and then from any other sources. Web of Science is good actually.
Yeah. But in this part of the world, they go for mainly Google Scholar.
It's good that if you can find, and sometimes Google Scholar doesn't give everything, isn't it? Just
Yeah.
you have to pay for some of them, isn't it?
Yeah, other question is outlier. Are you going to discuss later or?
Yeah, okay. I'll go back to the maybe I should go to the stop this one, and then yes, I got. If you have an outlier, it will show from this is the in here. You can see that if it is outlier, so it will come somewhere here or somewhere here.
Yeah. So we can just
So,
remove outlier.
yeah, maybe if you know that it is outlier, and if you can reasoning about the why it is outlier, then it is better to exclude that one, isn't it?
Yeah.
It depends on the on your research topic.
So you have to be thorough on the subject.
Yes,
Yes.
you cannot do meta-analysis without knowing the subject.
Yeah. Thank you.
At least read. Okay, the tip is that, I mean, what I'm doing is, if I won't do a meta-analysis, what I do is that first find the very recent paper, okay? And then go through its references list. And then that references list is my base. And then I find the relevant information and keywords, and from that very recent paper. Sometimes you can use the review papers, but that review papers are kind of like biased, isn't it? So most of the time it talk about favorable things, not the unfavorable things. So it's better to find a very recent, I mean, in my way. Okay, so anyway. Sorry about that. I'll just. Okay. We are up to here, isn't it? So publication bias, what we call this funnel plot. So it shows the effect size and also the study precision. So it gives you a minute to look at this publication funnel plot. Okay, so this dotted line is 95% confidence interval, and the middle line is the overall effect. And then if these are inside this triangle, then you are okay. There's no publication bias in this meta-analysis. So the more precise top of the study, top of the triangle, less precise bottom.
Can I ask question on that, ma'am?
Yeah.
So do you think that the less precise one can be excluded if you think that they are reasonably not good for the study
It's
after looking at
depends.
the funnel plot?
So the first thing we do is to have our research question, isn't it? So that research question can be used for that to whether these studies are, sometimes you know that the we use that research question, but not all the researchers are looking for that research question. They're doing some other things. So perhaps we could look at that. What are the research actually looking for? And then if there's any reason for removing that one. But as far as I understand that, if it is outside this triangle, then we kind of think about to excluding those.
Okay.
So this is annoying. So publication bias, non-reporting bias. Yes, excuse me. Sorry. Non-reporting bias and poor methodological quality leading to exaggerated effects, true heterogeneity and artifacts, and also sometimes chances are the because of this not inside the funnel dots. Okay, so as what I mean that each dot is a study. If it is outside, then there are some reasons. Those reasons are the one I put it here. So this Eggers test and trim and fill method, I think I'm going to show you when we are doing the hands-on exercise with the next week. So at that time, I'm going to explain that one, okay? So these are the some of the funnel plots. So as you can see, some of the things. So these things are maybe we shouldn't remove. We should remove from our study. So the funnel plots here is the examples of metaphor package funnel plots. So So okay, so we have effect sizes, and then we can analyze for the forest plot with the whole data set. And also we could use subgroup analysis for the for some sensitivity analysis or some kind of if we have some for example, high fertilizer usage and low fertilizer usage. So we could have subgroups like that. And also if that fertilizer groups, if you have the few other like 0 to 25 kilogram nutrients or things like that, if you have the few levels, then we can run the meta regression. I'm not going to explain this one by one with this method, and this is the this Matthias Herrera's book is really good at explaining the subgroup and analysis. But in the next week, I'm going to do a hands-on exercise of these two methods. So just recapping the meta-analysis steps. The first thing is we need to import the data. First thing is we need to have the database, and then import the data to software, and then the calculate effect size, and then look at the summary, fixed effects or random effects. But I mean that we need to look at the Q statistics and also I-square. And then we look at the publication bias. And then also we need to draw the forest plot, and then finally the subgroup or the meta regression analysis. There are many software available for meta-analysis, SPSS and Stata, and also R, and also MetaWin is this. Some Stata is, I think, not a free software. I don't know about SPSS. MetaWin also pre-packaged. Some of the comprehensive meta-analysis is also commercial packages. So those any of these things you can, even Excel you can use that for meta-analysis, but for the rough analysis. But R give you a more control over to making the graphs of forest plot or funnel plots. Okay, so these books last week I also talked about it. And stop sharing. Okay, so anyone has an idea of doing meta-analysis, or do you have any research questions? Do you need to do meta-analysis? Maybe not the undergraduate students, but for the research student or the staff. Any research questions or
You want something just to start this session, or our interest? Which one you?
I mean, if some students have ideas of doing meta-analysis, so whether I can help or not or something. Do you have anything, Vasanta?
I have a couple of things in my mind, but maybe yes, I will discuss with you because there
Okay.
are issues in one related to mushrooms, the other one on plant pathogen.
Okay.
Maybe I thought that's a good idea to have meta-analysis on that. Yeah, I will get back to you soon.
Oh, okay. Okay. I'm more than happy to help. Okay. So, and now in Sydney University, most of the in agriculture faculty, so students were asked to do the meta-analysis first to do anything about, I mean, PhD students. So the literature survey and then meta-analysis. So the thing is that if you do a meta-analysis, you have the database, and also if it is really good, you could publish. So there's two outputs from a meta-analysis. You are planning as the research or the student project, Vasanta?
Actually, as a small research, but
Okay.
students, they are already completed. But I'm going to have a couple of grants. Maybe I was thinking that we go for meta-analysis, especially on ethnomycological studies in
Okay.
Sri Lanka. Nobody probably has done it yet.
That's good.
I will anyway, yeah, come up with my ideas to you.
Okay.
Maybe we all can collaborate to the work.
Okay.
Thank you.
So happy
In,
to help.
Yes, in our department, we offer MSc in Green Technology degree program, MSc program. That is
Okay.
a 2-year work, coursework and 1-year research. Now they are at the end of second semester. That means within 2 years period, they are going to start their research. And I think those days they are finalizing their topics. And therefore, I think it is better to have some meta-analysis that experience for them before starting their research, no? Regarding related to literature, something like that, no?
Yes. I think someone wants me to show them how to develop the database, isn't it? So I'm not sure. He talked about little bit, but didn't go very much about it. So we can discuss with someone, and then first thing. So I'm planning for next week. I'm planning to show a kind of way to how to have the prepare database, and then effect sizes, and then different way of doing the effect size. Forest plot and also funnel plot, so maybe meta regression. So any other student or staff have the idea of meta-analysis, or just
Well, maybe I don't know whether you discussed this because I was joining profanos because of my traveling. So maybe it's a good idea if you can just, if you have done, don't worry about that, to differentiate meta-analysis with literature, I mean, review articles. And just quickly compare these two.
I think I talked a little bit about last week, isn't
Okay,
it?
then great. Okay, probably I missed that. Thank you.
Okay, so actually literature review, and then after that literature review, so it is more like we automatically generate a bias when you're doing literature review, isn't it? So the meta-analysis is more like we're looking at whether this is we could positive or negative results for our research question. Okay, so in a statistical, more statistical way. So, any questions from today's? I'm really sorry, it's really statistics. I actually skipped many of the slides with the equations and things, but I'm really sorry that those are the things basically we need to talk. Anything to explain or more, need more discussion?
Madam, excuse me.
Yeah.
Sorry, for a beginner like us, so do you have any tips to narrow down a research question? For example, like suppose that we have some kind of research interest in climate change, impacts on plants, things like that. So in that case, what are the strategies that we can follow to narrow down a topic before like initiating that, going through the literature review and preparing a database? So is it personal or like, do you have any tips to narrow down?
So the climate change and plants. Okay, so what we are measuring mostly about the yield, isn't it?
Yes, yes.
So the yield is that if you think about climate change, so we have to have the initial temperature or initial water level or things like that, isn't it?
Yes.
So then it's more like what we are looking at, differences of means of different treatments, isn't it? At least 2 treatments. So try to read few papers first, and then okay, for example, I'm not sure that which climate change you are think about. Just have the question next week, so I can help more with that if I know what you really need, because climate
Yes.
change is a very big topic, isn't it? So
Yes.
you could talk about even ice at in Antarctic or things, isn't it?
And also, madam, so in the next week, when we develop the database, so are you going to take an example and show us how to like fill the columns based on a specific question that you are going to select, or?
Oh, so I was planning to do something like that, but are you a student or a staff member?
I'm a staff member, probationary lecturer.
Okay, so I'll talk about with someone first, because I'm not sure that some of the students are doing this one for compulsory. So I'll talk about it and then with someone and then let you know. Okay, so
Okay, madam.
because I may not, I don't know. Sometimes you have to have a okay from the boss, isn't it?
Yes, the same department actually through Professor Saman, I think. It's
No, but I mean that if it is for the assessment purposes of the students, so and then at the end, so all the students write the same thing, then it's going to be a problem for the marking, isn't it? So, what do you think, Chita?
Yes, maybe I will discuss it Professor
That's
Saman.
right.
Yes, his course related to here.
Okay, so
Okay, are you going to conclude now?
I'm thinking about if you don't have any questions. So, any questions from today's talk?
Ma'am,
Excuse
do
me,
you
madam.
want
Yes.
anyone to make some preparations for the next week? Or having
Yes.
their own data set, or what do you expect from them?
That's why I had to talk to someone, and maybe I'm giving you a few papers and then try to have a table, summarize the research. I'll send the papers
Okay.
before and then.
I will circulate. Kindly send me in advance, then we can circulate among the participants.
I think good
Okay.
if you can have a common data set for everyone.
Yes,
So
yes,
that
yes. It
if
is
they
good.
find any errors and things, you can easily attend to those.
Okay. Okay.
So
So I'll
return, they
find
can go for their own. Yes.
Yeah. Okay. Any other things to
Excuse me,
discuss?
madam.
Yeah.
I have one thing to clarify. Thank you so much for your explanation so far. I just joined this session today only. I don't know whether you have explained it last session. This is to clarify about the databases that we gonna search on. I mean, is it, let's say that we are selecting Scopus and Web of Science for the for literature extraction, and
Yeah.
is it, and here we can freely access to the Google Scholar. So when we are extracting papers from Scopus and Web of Science, we can use these Boolean operators. But how can we, extract the literature from Google Scholar? It is very difficult to,
I'm really sorry. I didn't have I never used Google Scholar actually because we have Web of Science and university provide after us the free of charge. So what is exactly happening in Google Scholar? So just a PDF copy or?
No, it's like when we have given these keywords with Boolean operators in Scopus, let's say we ended up having like 1,000 papers, but in Google Scholar sometimes we are ended up having 150,000 papers, like so many papers are there. That's why. Or else, or if not, we can only use Scopus and Web of Science for our study, right?
Yeah, it's just if you want a kind of like even Web of Sciences, the last time I searched for it has a 300,000 something. So you just have to use the Boolean operators to narrow down what exactly what you need. Okay, so some keywords and it really depends on the research topic.
Okay, madam. Thank you.
Any other questions?
Hello.
Seems like, yep. Hi, Pumi.
Hello, madam. Madam, could you please explain mixed effect model other than fixed effect and random effect models?
Sorry, tell me again.
Madam, could you please explain mixed effect model other than fixed effect model and the random effect model?
You are asking a hardcore, isn't it? I haven't prepared anything for mixed effect models, but fixed effect model, random effects models. You are clear about that too, isn't it?
Yes, madam.
So what exactly you looking for mixed effect model? So what do you mean that both?
You mean, ma'am, when we considering about a particular research topic, we should have to analyze both fixed effect model and the random effect model at once.
So we first thing we do is to analyze as the fixed effect model, and then look at the heterogeneity, and then I square or Q statistics. Then if it is heterogeneity is non-significant or not considerable, then we could use the fixed effect model. If not, we have to go to the random effects models. The software can do it because the tau square is not easy to calculate or looking at. It's inside the software, it will do that for us, but I'm not sure that we could really think about it as the other way. I'll think about it and let you know the next week, okay?
Thank
And please put the question again in my email. You have my email, isn't it?
Yes, ma'am. I will. Thank you.
Okay. Any other questions? Hello, Shivaya.
Madam, I have a doubt about the publication bias that you have mentioned already.
Yeah.
That means you have mentioned to avoid the publication bias, we have to use so many databases. That, madam, I have now creating my database, but currently I'm using some papers in Google Scholar. Do I have to again repeat my to fill the database? That means from the Web of Sciences, from Scopus, like that, madam, or is it enough to have one paper? That means from Google Scholar.
So
Did
if
you
you
catch
have,
my question?
so Google Scholar, SciFinder Scholar, or the Web of Science, the same paper, I mean, same publication can appear in many databases, isn't it? So if you have one, find from one, maybe the same thing you could find from the other two databases. Someone before talked to about Malita, isn't it? So Malita, I talk about databases, means that the search engines and also databases specifically prepared for the meta-analysis. Okay, so I'm going to talk about that next week, about specifically how do you summarize your database for your meta-analysis. Okay. So the database has two meanings. That's what I want to explain it then. Okay, Shifaya. So can we discuss in a so someone is asking my email address. That's going to be how many here today? Now I remember last week is 70, so
Today started with around 44, 45 like this, but now
so,
maybe they are
okay.
The session may be over now, just discussion, therefore they may log out.
Okay. Okay, so maybe Chinta got my email address. Okay, so you gave the question to Chinta, and then I can send, because then it is one email. Otherwise, I may not look at many emails. Is that okay, Chinta?
Okay. I will do. Please, I request all participants, please, if you have any kind of any clarification, anything you need, you can write to me and I collect.
Or maybe we should start Google Doc or something.
Google, yes, Google Drive. Even Aravinda, you can prepare some Google Drive and share with participants.
Google Doc, isn't it? Google document that everyone can
And
see.
there are things, ne?
Yeah.
Yes, madam. Okay, give me 1 minute. I will give you the link so that everybody can include.
Okay. So Chinta can.
Maybe I can. Yes, maybe I can put it in the chat box
Now,
so the
ne?
people who are available,
Okay.
they can access.
Okay.
Yeah. So then everyone see the my answers and everyone see the others' questions, isn't it? So it will be easier for all of us.
Yes, that's fine. Otherwise, reading many mails, it's not.
Yeah, it's not. It's just
like a miss, no?
You always have at least 20 emails in the morning to see at, isn't it? So
unable to concentrate sometimes, no?
yeah, and sometimes you skip
Yeah.
everything. Okay, so is that all? So a little bit of summary from next week, and then we directly go through the analysis part or the workshop part. I hope that you guys can have the R and R Studio in your computers, and then I can proceed.
Even some document in advance, please send it to me, and then I will circulate among the things. Even we
Okay.
can use that Google Doc. Aravind already prepared. Please
Okay.
get that.
Madam, I think I shared the link so that all the participants can copy that link and paste it in their email or have a note that so that later they can access to the document and upload any question or
Even
incident.
Dr. Nirmala also can upload that document to that link, ne?
Yes.
Yeah, I
madam,
can.
do.
I can answer the questions straight away from
Yes.
that.
Also, your document also you hope to share with the participants also can be
Yeah, I can do
upload
that,
to
isn't
the
it?
link. Yes, right? Then it is better. Please.
So
Then
Aravind,
we
share
will-
this a Google Doc, not the folder.
Yeah,
You
yeah.
will. Okay, wait.
Better to share folder.
Thanks, Vasanta.
No worries, thank you. So how are you doing these days? Is it
Oh,
cold?
all right.
Start?
Very cold these days. This is the winter, middle of the
Okay.
winter, close to middle of the winter. So
Yeah.
it's not a good time for me. Okay, so it's just 13 degrees outside, but feel
Oh,
like
great.
9 degrees.
Yeah. But couple of months back, it was very hot. Is it?
Yeah. It's December is something like 45 degrees.
Yeah.
Something. Yeah.
So I used to talk to my sister. You have met her?
Yeah. Yeah, it's just I was in the last week, not last week before that one is very hot for me. Not hot, very humid.
Okay.
Okay, just I want to share some information, and the coming Wednesday also you can use the same link. I think
Okay.
no problem with the Zoom link, but I will check. If not, I will send new link. I think no problem. We can use same link. And please log in I kindly request for all the participants also kindly use the same link to log in the last workshop also. If there are no any questions, any clarification, may we conclude? Yes. Now Aravind share that informations, Google Drive. Please note that Google folder link.
It's working there now. The drive is shared.
Okay. Please.
You can upload the documents to that.
Okay. Thank you.
Then
Thanks, everyone.
thank you so much.
Thanks for joining.
Thank you so much
And
for
Thank you,
sharing
ma'am.
your
See
knowledge
you next
among our
week.
participants.
see you. Bye.
Thank you so much, and we will hope to meet you in coming next Wednesday. Probably Professor Saman will be there. Okay, thank you so much sharing your expertise knowledge among our undergraduate students, postgraduate students, and also some other participants in our science community, and also our academic staff members. Thank you so much.
Thanks for inviting. I hope this helped you guys. Okay. Bye.
Thank you,
Bye.
bye-bye.
Thank you, madam.
Thank you,
Thank you.
madam.